Hi, today we discuss 22.9 again. Uh, First we discuss stirling formula. So this is the stirling formula. To remember this formula, how you need to uh, remember this one. Here we have y naught. Here we have delta y minus 1. Here we have delta y naught, and on the center line we have delta square y minus 1, and here we can see delta cube y minus 2. Here we have delta cube y minus 1, and here we have delta raised to 4 y minus 2. Okay, so this is the way we choose the values from the table. First we choose y naught, then we take the average of these two numbers. Okay, so that is 1 by 2 times delta y naught plus delta y minus 1. Now we again come to this. Okay, so that is delta square x square by 2 factorial times. So please remember this. You need to remember these numbers, these coefficients, otherwise you cannot apply this formula. So please remember this. This is enough. This much term is enough, because we are doing problems up to this stage with the accuracy of these fourth order difference. So again we have averages of these two numbers, and then come to this. Okay, so this is the way we choose the coefficient from the table. In fact, this is the table what we have written. This, suppose this is y naught, here minus 1, y minus 2, y1, y2, etc. Then here we take first in the second column we have delta y minus 2. This is delta y minus 1, delta y naught, delta y1. Okay, then this will be delta square y minus 2. This is delta square y1, delta square this y minus 1. This is delta square y minus 1. This is delta square y naught. From this you can get delta q y minus 2. This is delta q y minus 1, and finally we have delta raised to 4 y minus 2. So this is the table. So we have written what this diagram means, that we from this table we first choose this value, then take the averages of these two numbers, then take this value, and take the averages of these two numbers, then take this. This is what we have written here or drawing here. This is the way to remember the terms in this formula along with these coefficients. So please try to remember this formula, otherwise you cannot perform the problem. So we describe it using or illustrate this with an example. So we start with an example. Given that the values of theta and the values of tan theta, we are given some angles: 0 degree, 5 degree, 10 degree, 15 degree, 20, 25, 30. So the corresponding tan values are 0. Here we have 0.0875. This is 0.1763. This is 0.2679. This is 0.364. This is 0.4663. Finally we have 0.5774. Okay, so how will you find this? This value of, or the question is using stirling formula, show that tan 16, or find the value of tan 16 degree. So this is the question. Now in order to evaluate tan 16, we set x. Okay, so first we need to set x or p, whatever be this number, so we need to set that. So we write it as x equal to theta minus 15 by 5, because this interval is of length 5, so theta minus 15 by 5 is the x value. Okay, so this theta, we have theta is equal to, we need to find tan 16. So x value at theta is equal to 16 is 16 minus 15 divided by 5, that is equal to 1 by 5 is equal to 0.2. Okay, now you evaluate yx. Okay, what is yx? Yx is perform this formula, that is y naught. Y naught is this one. Okay, so before that we need to set the table. So I'll write the table here. Okay, so please perform. I will give the values of table using the values of theta and tan theta. So these are the values. So I take 0, 5, 10, 15, 20, 25 and 30. So these are the values. So the corresponding x values are, these are theta, and corresponding x values are for these values we set x equal to we need to find out the 16 is somewhere here. So we set x naught is theta naught is equal to 15. So the x values in the previous problems we denoted this number as p. So the corresponding x value using this formula is 0 here. This is -1, -2, -3 and 1, 2, 3. Okay, now take the del y. Okay, so that is the difference between first we'll write the y values. Y values are 0.0875, 0.1763. so this is the second value. First value is 0.0875 and 0.1763, 0.2679, 0.3640, 0.4663, and we missed one thing. Okay, 1, 2, 3, 4, 5, 6, 7. We have 7 values. That is, if the first value is 0. Okay, so we write, these are the values. First value is 0, then we have this much values. These are the y value, and take delta y and delta delta square y and delta cube y and delta raised to 4y. So perform all this finding forward difference table. So take the difference between these two first, then write here, and difference here, difference here. So you complete this and choose the values starting from y naught. Okay, first you choose y naught. This is our y naught, since x naught is 15. Then choose these two values and take the averages of these two and multiply it with x, and then for the next value we choose this value here and multiply it with x square by 2 factorial and so on, and perform this. You can get the value of yx, that is tan 16 degree is equal to 0.286, okay, 671. So this is the value of tan 16 using the Stirling formula. Okay, next we discuss Bessel's formula. This is the Bessel's formula. So yx equal to 1 by 2, we starting with y1 plus y0, half of that, half of y1 plus y0, plus x minus half into delta y0, plus x into x minus 1 divided by 2 factorial into half of the average of these two numbers, and so on. So how will you remember this? So we start with this, remember the starting point, half of these two numbers. So we take these two numbers first, take the average of these two numbers. Okay, then come to this number, and the second term we have delta y0, that is because of this. Come to the center line, and again we take the difference average of these two numbers, delta square y minus 1 plus delta square y0, and take the average of these two, and again come to delta cube y minus 1. Then you take the other two, delta raised to 4 y minus 2 and delta raised to 4 that comes here, delta raised to 4 y minus 1. So take the average of these two. Okay, so this is the way we use the values from the tables to evaluate Bessel's formula. So please try to remember this formula, along with the coefficients. So you can easily remember this thing, but it is not so easy to remember all these coefficients. The first coefficient we have only this term, and the second term we have this coefficient x minus half and x into x minus 1 divided by 2 factorial, and so on. Okay, in the textbook you are given a illustrative example, so please try to work it out. That is a worked out example, so please try to work it out with the table. That is exactly same as the previous problems. This is nothing, the only thing is to construct the forward difference table. So here we use the forward difference tables to evaluate all these central difference central interpolation formula. Okay, so next class we will discuss other one central difference interpolations, say Laplace Evert's formula and divide difference formula, Newton's divide difference formula. So these are two remaining central interpolation formulas. Then we can conclude, after that we can conclude section 22.9. Okay, thank you.